Now, let's talk about genes. So many patients come in, and I get so many questions on it's genetic. Cancer's genetic. My diabetes is genetic. My joint pain's genetic. This is genetic. And so, what are they talking about? Well, let me tell you facts and delusions. Right now, the actual fact is 3% of diseases are genetic. That means 97% are not. So when you look at Down syndrome, that's a defect of the genes. That's a chromosomal defect. And that is a genetic disease. Now, there's a difference in gene and gene expression. And this is huge. So let's look at the Human Genome Project. Well, it was planned in 1984. They didn't start it until 1990. And it was finished in 2003. That means that they go through and they find a gene associated with a protein. And what the idea was in 84 when they started this is that the human body produces about 100,000 proteins. So there should be about 100,000 genes. Problem is, we got about 20,000 genes in the human being. And it's pretty similar to a mouse. So what's the difference? And what they found is that there's something different. There's a control above the genes. It's called epigenetic. This is why twins who have virtually the same genetic makeup, I'm talking identical twins, that they experience different states of disease. So there's an expression or a control above the genes. That's what epi means. And they've started the epigenetic project, which, let me tell you, it's going to be running in not 15 years. It'll probably be going 50 years. Because what factors control gene expression? And that's huge because you can express a gene that will cause cancer. You can express a gene that will eliminate cancer. So does that mean that you have the ability or the control of your genes? Yes, you do. See, everybody remembers back in school when you saw that picture of the cell. And that picture of the cell, remember, it was a round cell. It had a nucleus, and they had all of these, different organelles in there, like mitochondria and Golgi packaging apparatus, and the cell wall. Well, what they found, or what they thought, was that the nucleus was the reproductive aspect of the body. Because in the nucleus, that's where the DNA sequencing is. And depending on what part of that DNA, and figure it's called a double helix, which looks like a ladder that you twist. So it holds a tremendous amount of information in that DNA. However, so you're talking for decades, they were studying the DNA. And the only thing in the nucleus is DNA and a protein sheath. Well, they were throwing away the protein sheath when in actual fact, that protein sheet is a controlling protein. It actually can go down and expose the part of the DNA to be expressed. Now, how does that controlling protein operate? It operates through perception. That's right, the cell wall that is in contact with the environment or with the perceived environment, that's what operates the controlling protein to express the gene. So let me walk you through this again. Picture that cell, that round cell. We got the cell wall, and the cell wall is in contact with the environment. So if the environment is a stress environment, and that cell happens to be a cell inside the adrenal glands, then your body is going to be expressing adrenaline, epinephrine, norepinephrine, cortisol, all the stress hormones, based on what the environment is sending those signals to the cell. Let's say that you have a perception that a disease is genetic, but it takes you decades to develop that disease. That's right. Under decades of influences on that cell, your cell finally expresses those proteins that form into cancer, or that form into bowel disorders, or that form into autoimmune diseases. So there's a control above the genes. And this is why when people come in under the delusion that their disease is genetic, and I explain There's a difference in expression or in epigenetic control. Now, here's the scary part. Drugs that people are exposed to can have an epigenetic effect. That means that if you take a drug, it can cause your body to express a gene. So we're talking about, and here's just a short list of drugs that can alter gene expression. We're talking about cholesterol-lowering drugs, antidepressants, beta blockers, okay, which is typically used for cardiac arrhythmias or blood pressure, diuretics, which are also called water pills, methotrexate, which is used for autoimmune disorders, anti-inflammatories. This means the Advil, Motrin, Aleve. Yes, all of those non-steroidal anti-inflammatories can alter genetic expression. Anesthetics, antibiotics, oral contraceptives. All of these can alter genetic expression. As amazing as that is. So, see, every medication out there only does one of two things. It can either block a receptor site on a cell or poison an enzyme. So that's why when you see the commercials here in America, they actually allow the drug companies, it's called direct-to-consumer advertising, as psychotic as that is. Ask your doctor if it's right for you. Really? How does the doctor even know? That's insane. No doctor can know what the cholesterol-lowering drug does with the beta blocker and the birth control, and then toss in an antacid and a non-steroidal anti-inflammatory, and then you do that combination in 100 people? Come on. Let's wake up and smell the BS. Okay, so when we look at this, the genetic expression has to do, it's based on your perception of the environment. And your environment is going to be through a number of different factors. One of them is your perception. So in emotions are chemicals secreted by the brain based on your perception. And that's going to cause your body to express genetically your response to that environmental stimulus. So let me walk you through this. Let's say that you're looking at a puppy running through the field. Oh my goodness. So your brain starts to secrete chemicals or emotions, which are chemicals, based on that perception. Now, let's say that you perceive that puppy as joyous, okay? Then you're going to be producing more dopamine, a little bit more serotonin. You're going to feel all warm and fuzzy. But then let's say that you perceive that puppy has a nasty little ankle biter full of fleas. He's going to go nipping at it. So you're going to be secreting the emotional aspect of fear and stress. No, I don't have a dreaded fear of puppies. Stop thinking that. So when you look at this, okay, based on that perception, is you're going to have a different emotional aspect, which is going to cause an entirely different sequencing of genetic expression. Now, let's say you do something wild, and it's super common today that they're doing this, is that you're under the care of a physician who's giving you a chemical to alter your genetic expression. Do you think that's going to lead to different diseases? Absolutely. Absolutely. This is why the more drugs you're taking, the less anybody knows what the expression is going to be. So medications can cause, and it has an epigenetic effect. Your brain, your perception of the environment will control those genes. Your diet, nutrition will control your genetic expression. Your sleep patterns will control your genetic expression. So physical, chemical, and emotional stress loads will control or suppress your genetic expression. So you do have control of your genes 97% of the time. 3% of diseases are genetic, and those start in the womb. But think of this. If you develop a genetic expression of a disease decades after you've been alive, then that, my friend, was under your control. It was under your exposure to physical, chemical, or emotional stress load, and you're expressing that. And here's the neat part. You have control. You have the power over your genes. You are not a slave to your genes. You can control that expression through changing your physical, chemical, and emotional stressors. That's the exciting part. Through this series, we're going to be covering the physical stressors. We're going to be covering the chemical stressors. We're going to be covering the emotional stressors. We're going to give you back the power to take charge of that genetic expression. That's the key. It doesn't matter if every member of your family had cancer. Think of the members that didn't. If every member of your family, 5 uncles had rheumatoid arthritis, you can choose to express that gene or choose to suppress it. If several members of your family had irritable bowel syndrome or depression or anxiety, you can choose to express that or you can choose to suppress that. Yes, I'm putting the control back in your ballpark. You are going to take charge of your health. This is going to be a completely empowering process, because you can control your physical stressors. You can control your chemical stressors. And let me tell you, chemical stress is brought on or suppressed by getting deep sleep, by exercising, by changing your thought patterns, and by changing the nutrients you put in your system. You can control your emotional aspect as well by changing your perception of the events that are occurring. You can control each aspect of the stress. And I'm putting the control back in your ballpark. And we're going to be talking about to deal with the physical, chemical, and emotional stress load. And you are going to gain control of your genetic expression. That's the key. Not your genes. It's what you express, by gosh. Okay, you now have control of your genetic expression. Go forth.